So today we discuss about refraction of light at a plane surface, chapter number 4. Chapter number 4, refraction of light at a plane surface. Refraction of light at a plane surface. Okay. So what is refraction? Before refraction, we discuss what is reflection. We know that class 9, what and class 8, do you know what is reflection? Okay. So we ignore that part. Okay. So we know that all know that what is reflection. Now start the refraction. Okay. So in case of refraction, slightly we'll discuss about the reflection slightly. Okay. So here a plane surface. Okay, here is a plane surface. Okay, and this surface is also here as a divider. Okay, so that is a medium 1, and below that boundary there is a medium 2. Okay, so there is a source of light here. There is a source, a line, a ray of light from source is called incident ray. Incident ray. Okay, and this divider line is called line of incidence. Line of incidence. Okay, line of incidence. After striking that incident ray, now reflected back on same medium is called reflected ray, and this phenomenon is called reflection of light. Okay, that is this point is called point of incidence. This point is called point of incidence. Okay, and now draw a normal at point of incidence, that is a normal. Why this yellow color line is called normal? Because the yellow color line and the line of incidence make an angle of 90 degree. That's why this yellow color line is called normal. These are the normal. Okay, and that angle is called normal, and incident ray make an angle. This angle is called I, is called incidence angle. But angle I, and the normal and reflected ray makes the angle's name R, is called reflected angle. Reflected angle R. Okay, so that is a basic phenomena of reflection of light. And what is refraction? There at point of view, some part of ray, incident ray, some part of incident ray absorbed by the medium too. So some part of refraction starting, some part of incident ray absorbed by medium 2. Okay, and okay, there is the absorption here. Okay. Now if they absorb, we know that light follow the straight line. Okay, so that light goes in straight path. Okay, but there is a problem. The problem is that if medium 1 and medium 2 both have different densities, medium 1 have another type of density, medium 2 has another density. Okay. So if density of medium 2, so there are two cases. Okay, case number 1. So there is a case of medium 2. Density of medium 2, rho is a symbol of density, is greater than medium 1 density. So light goes from, in case of refraction, from rarer medium to denser medium. If light goes from rarer medium to denser medium, okay, so okay, suppose they do not follow the state path. They do not follow that state path. Okay, they do not follow the state path. There is a bending. Okay, there is a bending. If medium to light goes from rarer medium to denser medium, then refracted ray, if that green color represents the refracted ray, so that refracted ray bend towards normal. Then refracted ray bend towards normal. That is a refracted ray. Refracted ray. That's refracted ray bend. Refracted ray. Refracted ray bend toward normal. Okay, and these angles. Okay, the angle between refracted ray and normal. This also normal. Normal, because that line of incident and normal makes an angle 90 degree. Okay, this normal and refracted makes angle is called refracted angle, angle of refraction. Incident angle, angle of incident, or reflected angle, and there is a, suppose that is called R dash, represent the angle of refraction. So that is R dash represent the angle of refraction. Okay, and case number 1, the case number 1 know that if we will see that in diagram, angle of refraction is less than angle of incident. Okay, and you know that from laws of reflection, the angle of incident and always is equal to angle of reflected or reflection. Okay, reflected angle. So also R. Okay, the case number 1 case. Now another case, case number 2. Okay, case number 2 is there is a case number 2. Case number 2. If density of medium 2 is less than of density of medium 1. Now, so light travel from higher density to lower density. Here light travel from lower density to higher density. So the keynote light travel from higher density to lower density. Here light travel higher density to, sorry. There is a mistake. Light travel from lower density to higher density. Sorry. Light travel from lower density to higher density. Here light travel from higher density to lower density. Okay. So if light travel from higher to higher density, lower density, so reflected ray now bend towards normal. Previous case we discussed the bend towards normal. Now the refracted ray away from the normal. That case. So that so spring line represent the case number 2. That is the case 2. That is the case 1. Here refracted ray. Case 2 away from the normal. Okay. So refracted ray away from normal. Here is a towards normal, here is a away from normal. Okay. So that's angle now normal to refracted ray makes an angle that is R double dash here, and that is R double dash, that is a refracted angle here. R double dash represent refracted angle as the R double dash here. You see that is greater than R dash, and R double dash angle is also greater than angle I. R double dash angle also greater than angle R also. Okay. So here, so here, see the diagram. So actually you know that the light traveling straight line. Okay. Actually light goes from these dotted red line. Okay. But due to the mismatching of density of the medium 1 and medium 2, so that refracted ray they bend. Okay. Either towards normal or away from normal. So here we get some deviation of refracted ray from incident ray, path of the incident ray. So here is the deviation. If case 1, so we draw the diagram. If that is the incident ray, that is normal. If that is density medium 1, that is a medium 2, density of medium 2 is greater than density of medium 1. Okay, so that is that know that light traveling straight path, if they are in density of the both medium are same, but in case of light travels from higher density to lower density, they bend towards normal. So bend towards normal, that is the angle of that is the angle of R dash. So there is a deviation, that is a shift or deviation. Okay, that is a deviate. That is ray actually follow that path, but in case of mismatch of the density of two mediums, the light travel that path. Okay, so there is a deviated angle. Okay, so the delta is called deviated. Okay, okay, so here that we see that in diagram. So angle I also equal to angle R. That angle R is reflected angle. That is also equal to refracted angle plus delta. Okay. So here we see that I equal to R dash plus delta. Okay. Now another diagram, if another diagram, case 2, that is a incident ray, that is a reflected ray, that normal, that is that actual straight line path, if both are density of the same in both medium. Actually it's not. Okay, there is a case 1 and case 2. If that is a medium 1 density, that is medium 2 density. Here medium 1, that case if medium 1 density, okay, is medium 1 density is greater than density of medium 2. Okay, so now light travel from high density to low density. So uh, refracted ray bends away from normal. So that is that refracted ray. So that is R double dash. That is I and that is R. R. So that is the original path. Now shift, that is a delta. Okay, that is a deviated angle. A deviated angle is inside, the deviated angle is outside. So in that case, we compare the diagram, tell that that is angle incident ray, that is equal to refracted angle is greater than incident angle here. Now is minus delta. And also R reflected angle, refracted angle minus delta in case number 2. What is the delta? Delta is the deviated angle. So here delta equal to R dash minus I, and here delta equal to R double dash, sorry, that is delta equal to angle I minus dash, here R double dash minus R, or delta equal to R double dash minus angle I. Okay, clear? Now the causes of refraction. So changes of direction is the main cause, is the density difference of two medium. The main cause of that deviated angle, main cause is mismatch of density. Mismatch of density. Okay, either they greater than 1 or less than 1. If delta is 0, when angle delta is 0 degree, when density of medium 1, that is equal density of medium 2. Okay. So continuation of the previous topic. Okay. So refraction of light at a plane surface. Okay. So previous class we discussed the medium mismatch, density mismatch, what is the deviated angle and what is refraction, basic. Okay. Now there is a laws of refraction. That's the important point. Laws of refraction. Okay. So what is the laws of refraction? First law. First, understanding the laws of reflection, first we draw a diagram. Okay. As the incident ray, arrow is very important. Okay. Without arrow, we can't tell light goes from that point to that point. There's a east source and destination not defined without arrow. So arrow is mandatory. Okay. Incident ray, reflected ray, that is a normal, that is a bending towards normal or away from normal. Okay. That normal is not look like a normal. That's a normal. Okay. That's the point of incidence. That is the line of incidence. Okay. So first law, law number 1, state that incident ray, incident ray, that is the incident ray. Okay. And refracted ray, that is the refracted ray. Refracted ray. What is refracted ray? Incident ray, refracted ray, and the normal, that is the normal, and normal. No. At the point of incidence, at that point of incidence, at the point of incidence, at the point of incidence, that is the point of incidence. Okay, all lie in the same plane. All lie in the same plane. Okay, there suppose that is a graphic represent, that is a x and y. That is a same plane. All lies in the same plane. So that is a xy plane. It lies on xy plane. Okay, and that is number 2 law. Ratio of the sine of incident angle. The ratio of the sine of incident angle in the I to the refracted angle R dash. Okay, that is represent the R dash dash. Okay, is a constant. Mathematically, the sine I by sine R dash, that is equal to a constant name is mu. Name is mu. That constant name is mu. The symbol is mu, and name is refractive index, Ri. Okay. So Ri is a parameter. Okay. Ri is a parameter. That parameter defines some important factor. Okay. Ri is a parameter. From light goes here to density, speed of light. They also depend on wavelength of light. Okay. There is a parameter. Clear? That is very important point. Write the laws of reflection, class 10 board question. Very important question. Next, Ri is a constant, so that's why the is a unitless, because the I same the angle by angle. Okay, actually angle by angle the same quantities, but that's why there is a unitless quantity. I is a parameter. Okay. Now, effect of speed, frequency, and wavelength. Now the relation between or effect of speed means v, frequency of light, that is f, and wavelength lambda. Okay, So we know that from basic equation, okay, speed, distance, time, the velocity equal to, okay, wavelength is SMT is meter, length, distance by time, and the frequency equal to know that is 1 by time period t. So that is equal to 1 by t times lambda, that is f lambda. So v equal to f lambda. Okay. So if velocity increases, wavelength also increases. If frequency constant, if velocity decreases, wavelength also decreases. Okay. Now next. So they are them directly proportional. So V directly proportional to lambda. Now, if lambda equal to V over F, if velocity same, if now the velocity same is velocity constant, so lambda and frequency they are inversely proportional. If lambda increases, so frequency decreases. And next case, if lambda decreases, so frequency increases. Okay, so that is they are the inversely proportional. Yeah. So today I end the class here. Thank you.